Hey guys, it's Miss Johnson here, and I'm here to bring you our 6-6 notes video. This is our last notes video for chapter 6. And today we are talking about solving polynomial equations. Now, in order to solve polynomial equations, we need to be able to factor them. And remember that factoring is the same thing as undoing multiplication. So we're just going to review some factoring of straight quadratics, which we've done lots of times since algebra. And we're going to practice a couple today. So let's take a look at number 1. In number 1, we need to factor 2x squared minus 7x minus 15. And so I first need to start by multiplying my first term and my last term, which gives me negative 30. And I want a product of negative 30 and a sum of negative 7. So the two numbers that give me that are negative 10 and positive 3. Now this is where I'm going to split the middle term. Let's just get that out of the way for now. I'm going to split my middle term. So I'm getting rid of that negative 7x, and I'm going to put in the negative 10x and the positive 3x. So I have 2x squared minus 10x plus 3x minus 15. And then I'm going to go ahead and factor by grouping. So I group the first two and I group the last two. From the first two, I'm looking for a GCF I can take out. I can take out 2 and x. So I take out 2x, that leaves me with x minus 5. From the second group, I can take out a 3, so positive 3, and that leaves me again with x minus 5 once I divide that term out. And then putting my factors together, the outsides make 1, 2x plus 3, and the insides make another x minus 5. So that's my factored form of that quadratic expression. Let's take a look at number 2. In number 2, I notice that there's only 2 terms. Now it looks like there's a lot of stuff going on there, but there's actually only 2 terms. Here's 1, here's 2. Remember that terms are separated by addition and subtraction. So in this case, I only have 2. Now I want to see if they're a difference of 2 perfect squares. Well, right away, that's addition. So they're not a difference of 2 perfect squares because I would need subtraction in the middle. So now the only thing that I can do to factor this is to look for any GCFs that can come out. So I'm just going to take apart each part. From 25 and 15, I can take out a 5. So that's part of my GCF. From a to the third and a squared, I'm going to take out a squared. I can take out 2 of them. And from b to the fifth and b to the sixth, I can take out b to the fifth. So that's my GCF, and now I have to put inside what's left over. So when I take 25 and divide by 5, I have 5 left over. A to the third divided by a squared is a left over, and b to the fifth divided by b to the fifth is 1, so that one I'm done with. From the second term, now I'm adding these, so there's a plus in the middle. From the second term, 15 divided by 5 is 3. A squared divided by a squared is 1, so that one's gone. B to the sixth divided by b to the fifth is b. So that is what's left over once I take that GCF out. So there's my factored form of that expression. And now the very last one, and again, I want to check and see, there's only 2 terms here, so I need to see if they're a difference of 2 perfect squares. X squared is a perfect square, 81 is a perfect square, and this is a difference. So that is what I have here. It's a difference of 2 perfect squares. Now I want to see if you can pause the video at this time and remember what would happen if we factor a difference of 2 perfect squares. Remember, you're going to end up with 2 factors here. They're going to look like that. Okay. Let's move on and talk about what we do when we factor polynomials. Now, the first thing we need to think about is when factoring polynomials, we have to take out a GCF. That's the first thing that we do. We have to take out the GCF if possible. Okay. Then some other things that I need to keep track of or think of. I've got some factor patterns here that might be new to us. Difference of 2 perfect squares we just kind of talked about, and you've seen these before. A difference of 2 perfect squares looks like that. When you have one term squared and another term squared and you're subtracting the 2, you take the square root of both. You've got 2 factors, one that's adding the factors and one that's subtracting them. The other 2 you probably haven't seen before. So I'm going to show them to you and then give you you can go ahead and pause the video and take a minute to write them down. So there's a sum of 2 cubes and a difference of 2 cubes. Sum of 2 cubes and difference of 2 cubes. Now we're going to think about taking the cube root of these things. Cube root, not square root, but cube root. And it's a little bit different way of thinking. And what happens here is that we have the cube root outside Okay, and in a sum of two cubes, it's added. In a difference of two cubes, it's subtracted. And then the resulting is a perfect square trinomial, which we've seen before. We know about perfect square trinomials, okay? So that's our factor patterns for the sum of two cubes and difference of two cubes. Great, so let's do some practice with this. I'm going to take a look at number 4. In number 4, it says factor out the GCF. We want to factor the following polynomials, and in number 4, they're giving us a hint here that we're just looking for a GCF. So if I take a look at these three terms, I have three terms now, and I look for a GCF, I notice that 2 divides out of all of my numbers, so I know that 2 is part of my GCF. I also notice that here I have an x squared, there I have an x, there I have an x to the third. So the biggest one that I can take out, or the greatest common factor, is an x. And then my y's, I have a y squared, and a y. So the biggest one, again, I can take out is a y. That's my GCF. Now I have to take a look at what's left. Okay, so this is my GCF. And now I want to take a look at what's left. So when I divide these things out, 6 divided by 2 gives me 3. X squared divided by x gives me x. Y squared divided by y gives me y. In the second term, 2 divided by 2 is 1. That's done. We're done with that. X divided by x, or is 1. We're done with that. And y squared divided by y is y. So the middle term, I just have a y left. And then in the last term, 6 divided by 2 is again 3. X to the third divided by x is x squared, and y divided by y is 1, so I'm done with that. So that's my factored form of that expression. I want you to pause the video at this time and see if you can finish number 5 on your own. Remember, you're looking for a GCF there. Okay, so let's move on and take a look at number 6. Now I'm factoring by grouping. Anytime you have 4 terms, if you have 4 terms laid out for you like we do here, 1, 2, 3, and 4, I can factor by grouping. Okay, so that's what I want to do. So when I factor by grouping, I group the first 2 and I group the last 2. So in number 6, I have these 2 together and I have those 2 together. And now I want to look for the GCF in each. Okay, so if I look at the first group, I have a to the third minus 4a squared. I can take out an a squared. When I take out a squared, that leaves me with a minus 4 inside. A to the third divided by a squared is a. 4a squared divided by a squared is 4, and they're being subtracted, so I have subtraction in the middle. Of the second group, I have 3a and negative 12. I can take out a 3. There's a common factor of 3 in both of those. And when I do that, I'm left with a minus 4. Okay, now the way we know we've done this right is that your insides should match, and they do. I have a minus 4 and a minus 4. So my factored form here is a squared plus 3 and a minus 4. Okay, a squared plus 3 and a minus 4. I want you to see if you can pause the video at this time and take a look at number 7. Try to factor that by grouping. See if you can factor that by grouping on your own. All right, we're just going to do the last 2 questions on the page. These have to do with those factor patterns that you saw. Look for the factor patterns. Now, I only have 2 terms in number 8 and 9, so I need to check and make sure, do they fit any of those 3 patterns? Do they fit the difference of 2 squares? Do they fit the sum of 2 squares? Do they fit the difference of 2 cubes? In number 8, I have a sum of 2 cubes. Okay, a sum of 2 cubes. If I take the cube root, not square root, but cube root of x to the third, I get x. If I take the cube root of 125, I get 5. Now this is the sum of 2 cubes, so I'm going to follow that middle pattern that's up there in that table we filled out. My factored form, on the outside I have x plus 5 for sum of 2 cubes, and then on the inside I'm going to have x squared and then minus 5x, because I need to put those 2 together, a times b, and then plus 5 squared, which is 25. Oops. 25 there. And that's my factored form, okay? X squared minus 5x plus 25. So I have a factor pattern there that I can look at. When I take a look at number 9, again, I have this time I have a difference of two cubes. I can take the cube root of the first one and I can take the cube root of the second one. When I take the cube root of 8x to the third, I get 2x. When I take the cube root of 27, I get 3. And all that means there is that when you multiply these things 3 times, 2x times 2x times 2x, that gives me 8x to the third. Same thing over here. When I do 3 times 3 times 3, I get 27. That's why we call it the cube root, because it's used 3 times. So now let's put that in that factor pattern. So now I'm following the last one, difference of two cubes. I have 2x minus 3 on the outside, because I want to take the sum of those. Then on the inside, I need the first term squared. So 2x squared would be 4 times x squared. In the middle term, I need to multiply those two together. 2x times 3 is 6x, so I'm going to add 6x. And then the last term is that term squared, so 3 times 3 is 9. And that is my factored form. Okay. So we're going to go ahead and stop the video at this time. Thanks for watching today, and we will come back together and finish our notes tomorrow. Have a great night.